I want to start this video presentation by showing you where I drew my fixturing and tooling for my robot simulations. And I start with AutoCAD. So I make simple representations of machines, and I just made them on, say, AutoCAD, so you can see my designs are like simple. This here represents a etching, laser etching, and camera inspection of the barcode etched on the part, um, which is just a simple. I try to keep it simple, not elaborate, because I don't like the simulation to be clustered with the unnecessary details. So I can focus on the actual path and functionality of the machine without the bells and whistles of it. This here is the stripped down version of the actual machine where the parts are going to be etched. So if I were to show you the actual part, the actual machine, sorry, it's going to be more complex than this. It's not just a prism and a disc on top. It's more elaborate. But here, the part, which is a round cylindrical sheet metal part, is going to be placed and held, clamped, and then etched with YAG laser with some serial number and a barcode. It's going to look a lot more complex than this, but this is the bare minimum representation of that machine. Now I'm going to show you other machines. I'm going to close this. And no, I don't want to save changes. I'm going to open the other designs I have. This here is another machine. This is a spot welder with 4 stations that will spot weld different features on the part, and it's just a very minimal representation of a spot welder. This is just represents the fixture, but the electrode and the gun and everything else will look nothing like this. But this is the representation, if you will, a symbol, more likely, of. But the spatial representation of the equipment, it's like this. So the crucial areas are these. This is where the parts are going to be placed and removed from. So, like I said, it's just a simple set of geometric forms that represent a more complex set of equipment. And for last, I have a conveyor, which is a double twin conveyor. Actually, this is a very simple representation of it. It's actually a double conveyor. One side moves one direction, and the other one goes in the other direction. They have servos attached to it, so it will advance a certain length depending on the part size. And I had photo eyes on them, knowing that there's a part present, and so on, and one at the end telling you the part it's full with parts and stuff. So of course there's a lot more to the actual conveyor than this, but this is a very minimum representation for the robot spatial design. The actual design in AutoCAD is far more complex than that, and I don't have the actual drawings of that. This is just a bare representation of that. But for the sake of speed and cycle and programming decisions, this is what I need, nothing more than this. So, the way I do this, I make this a 3D model, and then I just export it as a STL file, That's how I get it in Roboguide. So let me go to Roboguide here and show you what I'm talking about. Okay, so this is the Roboguide handling tool programming environment. You'll see your cell being loaded, and you'll start seeing all the this is actually the controller booting up, the virtual robot booting up. It goes through the same stages as a normal Fanuc robot goes. And the environment will start loading all the machines and fixtures that you have added into your project tree. Then you can, when you add something, when you add a machine or a fixture, then you need to move it into spatial Cartesian coordinates, X, Y, and Z, and then that would PR. So you kind of distribute the layout according to your needs, and it will let you obviously know this is a project tree. This is how many programs I've loaded, written in the controller. These are my machines. If I program, these are machines 1, 2, and 3. I'm just gonna collapse the project tree here. So this is the robot cell. Those lines represent the paths the robot has moved through when running my program. And one thing I want Guy to show you is how I approach this problem. This is a proposal I'm trying to get approved by upper management about automating a cell, a spot welder cell. So I proposed adding a final robot, which is like $46,000, and all the miscellaneous. Probably we need to upgrade this machine, and this new conveyor, we'll need to get a new conveyor that behaves like this, has 2 sides and has servo control and stuff. So the way I approached this, I wanted to use parametric programming as much as possible. And if you look at, say, my pick from load machine program, if you look at it, you see that I'm using arguments here. You can see the argument instruction being used. So R11 is the spindle count. R11 has values, integer values of 1 through 4. So I call this spindles, although they're not spindles. Actually, they're like fixtures, spot welder fixtures, but I call them spindles. So just imagine it was a milling machine. So this represents a spot welder. Spot, I can later rename this as spot count 1, 2, 3, 4. And this takes the value of whatever argument is passed on to the call of this load machine program. And I move to J2, to point 2, which is right in front of the machine, this point right here. This is point right in the front of the machine. And I'm also using registers as, the joint speed and the contour approximation. I'm using registers for that, so I can change it on the fly and see what suits me better. If I use CNT of 100 or CST of 50 or CST of 33 and so on. And the way I also did this is I using offset, using a position register. So I'm also using I equal my position, my current, the last fine motion where it loads the spot welder. Because this is parametric, I'm using a PR, and the PR takes the value of the current point and is offset by the amount on Y. So this here is axis Y. So I run this machine is aligned with the y-axis. So from spindle 1 or fixture 1 to fixture 2, 3, and 4, that is 250 millimeters between centers. So all it does, it just moves. If spindle 1 is being used, then it is 0. And if it's spindle 2 or fixture 2, it adds to the same position 250. And if it's 2, it adds 500. And if it's the fourth, it adds to that point 750. And I'm accomplishing that by using a position register that has its y coordinate added to the product of multiplying the offset distance by the spindle count, which comes from the argument I'm passing down into this program. And then it goes back to the position in front of the machine, and then it terminates. It completes, and it goes back to the main. Now I'm going to avoid that and go select another program that I use for load machine to table, which is this one here. I'm also using arguments in this. I wanted this program to be used as a two-way. So on the way from the machine to the table, when the machine is done with the part and you're ready to offload it, it will go through the table where it's going to be laser etched, and then gauge scan for the barcode, and then it's going to go into the table and be offloaded, and then the robot is going to load another part or get another part from the in-feed conveyor, which is this one here, and then it's going to go not through the table, but instead it's going to skip that point and go straight this way and load it into the corresponding spindle. Spindle 1 is being done, and spindle 2, and so on and so on. So that's kind of like the way I imagine this. So the same program, depending on what argument is passed, if it's argument 1, is going to go through this label, is going to go to this label, so it's going to jump to the label that is on register 5, which register 5 is the direction to go. This is how I label it, which equals the argument that is being passed into this machine to table call. So depending on the value of the argument, it jumps to label 1 or it jumps to label 2. And I just have wait instructions when it loads and unloads, because right now I don't have no gripper, so I have no IOs. I will then later on replace this with actual IO calls to a open gripper, close gripper, whatever. Then the handshaking signals with the table, the spot welder, and the conveyor. That's all going to be integrated. But this is just for how to arrange the robot cell, and of course how to write the programs. So and also